Our next unit is solving inequalities. So first of all, we're going to look at what the definition of an inequality is, and it's simply an unequal relationship. So you've probably seen inequality symbols before. My guess is these first four are quite familiar to you. We have greater than, less than, greater than or equal to, less than or equal to, and then there's also this last one, which is simply not equal to. So first of all, we're going to explore this inequality relationship. Our essential question today is, how does solving inequalities compare to solving equations? And that's what we're going to find out when we do our investigation. So first of all, I'm starting with an inequality that we know is true. We know that -2 is less than 4. And we're going to see what happens to this inequality if we add or subtract 2, and if we add or subtract -2. So first of all, golden rule, we're going to be adding and subtracting to both sides. So adding 2 to both sides of my inequality gives me 0 is less than 6, which is also true. So adding a number or adding a value to both sides of an inequality keeps the inequality true. So let's see what happens when we subtract 2 from both sides of our inequality. Subtracting 2, -2 minus 2 is -4, less than 4 minus 2 is 2. Well, -4 is less than 2, so that's still a true statement. Let's see what happens when we add or subtract -2. Starting with our inequality, -2 is less than 4. If we add -2, that's the same as subtracting 2. So I still get -4 is less than 2, which is still true. And finally, if I subtract -2 from my inequality, with our subtracting rule of add the opposite, we can turn our subtracting a negative into adding, and that's the same as the first one that we saw when we added 2 to both sides. 0 is less than 6. So adding or subtracting any value to both sides of an inequality keeps your inequality true. Next, we're going to see what happens when we multiply or divide that inequality by a positive or negative. So first of all, setting up our inequality, multiplying both sides by a +2, we get -4 is less than 8, which is also true. Dividing both sides by a +2, this time I get -1 is less than 2, which is still true. So multiplying or dividing both sides of an inequality by a positive keeps the inequality statement true. So far, solving an inequality is exactly like solving an equation. You just apply the golden rule to both sides of the inequality, and the inequality will remain true. So our last investigation, we've got to see what happens when we multiply or divide both sides by a negative. -2 times -2 is 4. 4 times -2 is -8. So we end up with an inequality 4 is less than -8, which is not true. So in order to fix that untrue statement, what we have to do when we multiply both sides of an inequality by a negative, we need to flip the sign so that the inequality remains true. 4 is greater than -8 is our true inequality. And the last one we need to look at is what happens when we divide both sides of an inequality by a negative. So dividing both sides by -2, we get 1 is less than -2. Once again, we got an inequality that is not true. So when we divide both sides by a negative, we need to flip the inequality to make it true. So again, to kind of recap what we just learned in our investigation, if we multiply or divide an inequality by a negative, we need to flip the inequality symbol to keep it a true statement. Anything else that we do to an inequality, adding, subtracting, or multiplying or dividing by a positive, the inequality symbol stays the way it is.